Hi, everybody. It's Fraser Cain here. I'm the publisher of Universe Today, and we're going to do a very impromptu seat of our pants virtual star party tonight. Oh, I see it coming back with the Neptune edition. In that Mike Phillips is in North Carolina and has been getting images of Neptune tonight, but unfortunately, oh, there it is.
It's coming back. I got Rachel Duke here with me too. Actually, we're hanging out together.
Oh, that looks great. Okay.
It's a two-man party to get Neptune tonight.
Yeah. So what's happening is that it's very low on the horizon, and it's actually going behind some trees in his backyard, and so it's coming and going, and so we're not going to have Neptune for very long. But right now, there is Neptune. So I think again, Mike Phillips brings us another virtual star party first. Last time he brought us Pluto. Now he's brought us Neptune. Look at that. Now it's super bright.
Way to go,
so
Mike.
That's fantastic. That is awesome.
Good timing.
Yep, good job, Mike.
Nice work. All right, everybody, remember that this happened.
Awesome.
It's because it's it's a great big green blob. Now you said that you can see Triton in this image, right, Mike?
Yeah, let's see. Now that it's bright enough, we can try and make it a little bit brighter here. This is a 2-second exposure as it is. We were looking at it at a quarter-second before, so it might not show up here.
Try a longer exposure, yeah.
Yeah, this is 4. Let's see.
This is the first time that we've done like a long exposure on a planet, though, right? I mean, most of the time we're doing just live video with the planets and the moon because they're just so bright. But in this case, we've actually got such a dim object that you actually do want to do a longer exposure. So joining me tonight, and again, I'm not entirely sure how this is all going to roll. So we've got Corey Schmitz, who is dark right now. Hey, Corey. Oh, he's trying. He just said he's trying. So
sorry,
we'll see what happens.
I'm working with my dot that I did not drift a line or anything, but I've got it pointed south at my light dome with a filter.
Yeah.
So I'm trying to get a nebula going.
I'm sure you'll find something.
Well, I've got the swan up. I'm just not sure if it's worthy.
Oh, for sure. Bring it in.
Yeah, go for it.
And then we got John Kramer, and John actually has a cool little nebula. John, what is that?
That is NGC 760 or 7662, the Blue Snowball Nebula.
And we just lost it.
And you just lost it. All right. Let me go back here and bring it on.
I like
back
that you're using
in.
lower third with you put Neptune as your What's your title, Mike? Mike Phillips.
I'm from Neptune, so
reporting live from
Live
Neptune.
from it.
Is Mike Phillips. Mite, what's the weather like?
Kind of an ambiguous-looking thing, so I thought maybe I should label it some way, but also give myself credit. Right?
It looks really beautiful now. That's amazing. You can see the real disc-likeness of it. And so then joining us for color commentary as well, we've got Gary Gonnella, who for like the first time I think in a year has cloudy skies. This has got to be a first for you.
It's been a while.
Yeah, because you live in a place where it never rains, it's never cloudy, you're always there, you're like a rock. But today you've got thunder showers there, right?
It's because you have your new building that you have all set up.
Yes.
Yeah.
And now.
Right.
You were here when I fell through the ceiling, weren't you, Scott?
Yeah, I was there.
You fell through the ceiling?
Can you see that on my arm?
Okay, that's too much sharing.
Ouch. And then joining us as well is my partner in crime, Dr. Pamela Gay,
Hi.
professor at Southern Illinois University, and my co-host on Astronomy Cast. And thanks to everyone for their patience. We're actually going to be starting up recording again. We recorded last week at Dragon Con, which was fantastic, and then we're going to start recording again tomorrow. No! Tree branches. Goodbye, Neptune.
Oh. And I missed you at Dragon Con, Fraser.
You were there?
I was there Saturday. I got to meet Pamela and Dr. Phil.
Oh, okay.
So I met Dr. Pamela Gay and Dr. Phil played, and that was in front of the CosmoQuest booth.
Yeah, we were all there, we were often in a crowd, so you probably, but I wasn't, Next year. And then, of course, my other partner in crime, Scott Lewis.
Hi, everyone.
And and I guess you're getting geared up. One thing that we should probably announce to people is that we're going to be all participating in the International Observe the Moon Night, and this is going to be a night when everybody across the world observes the moon, and we're going to do it virtual party style, and that we're going to get a whole bunch of telescopes pointed at the moon all at the same time, pointing at different spots, different resolution from different locations, and try and do our part for science. So Pamela, what is this International Observe the Moon thing?
It's a celebration that reminds us that we all share not just one sky but one moon, and encourages people to think about both the role that the moon plays in our scientific understanding of our solar system, but also in our cultural understanding. So this is an interesting celebration where people are encouraged to share both what are their cultural understandings of the moon, their mythologies, but also while they're doing that, take the time out to learn our modern understanding of the moon that's coming to us thanks to LRO, Grail, Kogoya, all of these fabulous missions that have been out there exploring for the past several years.
Okay, Mike, now you're just showing off. No, I'm on a Triton hunt here. It was down in this lower corner here, and I don't know that I see it yet.
Well, so. Can you go back to that long exposure though? Because that was fantastic.
You mean the one where it was all about here, maybe? That was a 6.8. Let's see.
Yeah, the one that you just had was great.
Right there, that one.
Yeah.
That's too bright. I think.
No, it's not.
You like it?
Remember, you got to think it's television. The camera adds 10 pounds.
That's right.
Can we get it to add 10,000 photons instead?
For us.
Yeah, exactly. Oh, hey, Emily's going to join us. Well, this is it. This is fantastic. I think we can all die happy now. We got Neptune. Although we still haven't got...
I have much more I want to observe before I die happy.
Well, we're still missing one object then. We still haven't got captured Uranus in a hangout yet. So
that'll be my next too. I'll deliver that one too.
Although Ahmet Kil last week did have Uranus up from Turkey with his new camera. Yeah, I put some images up on Google Plus on last Friday. Actually.
Oh, cool.
And it was
okay,
awesome.
I'll check that out. Awesome. Yeah. Hi, Emily.
Hi there.
Hi, Emily.
What's going
Emily
on?
For the Planetary Society, and there's a planet there.
There is a planet, and I'm very excited to see it. It's one of my favorite underappreciated sorts of planets, an ice giant.
Now, we used to learn that these things were called gas giants, and then they went and renamed them ice giants. What's the designation between an ice giant and a gas giant?
Actually, I should know more about that than I do. I don't think these things have quite as much hydrogen and helium, though, as Jupiter and Saturn do. I think that's the major distinction. There's a couple of different classes of planets, and we're, I think, getting a lot more interested in Uranus and Neptune now because we're discovering all these exoplanetary systems that have a lot of Neptunes in them. And so they've suddenly become a lot more exciting, I think, even to astronomers than they used to be.
Mike, can you go back to the longer exposure view?
I can, but so the thing with the longer exposure though is it actually washes it out, and you can't tell that it's a disk.
No, I totally disagree.
Just if you get just the right frame, you can tell it's a disk.
This looks
we were looking at stars before, and it was really hard to tell if it was a planet or a star, and we very firmly convinced ourselves when we got the right exposure that this is actually a disk and not an overexposed star. So I can go back to that one, but you'll see that it just washes out, and what happens is it looks like all the other stars when they're washed out, too.
No, it looks totally different.
Mitch said he thought it cleared the trees now, so maybe we can actually get Triton here. I'm going for 4 seconds. Yeah, I did adjust the focus on it, too. What happened?
So what are the specifics here that you guys are using? You're using the big Newtonian?
Yes.
There it is.
Yeah, so there's Triton. Triton's down here if we wait for there. So you can see there was one hot pixel that actually moves with respect to the other ones, so that's Triton. I don't know if we can make it out there or not, in between the sub-exposures here. Yeah,
now,
so
when you say that it moves, what do you mean by that?
Yeah, so you see there's a lot of hot pixels on here that don't move, right? There's green and red pixels here that don't move, but you see as Neptune is drifting through the field of view here, it's dragging a little blob of a piece of light here with it. That's there. It's right there underneath the mouse cursor. So you watch that move.
Right, but why? I mean, why is it moving compared to the background stars?
So the tracking on my telescope isn't perfect, and what's happening is Neptune is actually drifting through my field of view.
Okay.
And it's riding Triton with it, obviously, because they're gravitationally bound.
But is it actually moving to those background stars? Because
no. Those aren't stars. Those are defects in his CCD.
Ah, okay.
There's a star over there. This is Triton right here.
Oh, so these are defects. Okay, I guess I was wondering because I don't know if you remember
you thought it
when we
looked
were
pretty,
observing.
but it's not.
Yeah, well, we were observing that asteroid a couple of months ago.
Yeah, even
and
asteroids don't move that fast relative to the stars.
I didn't think so, so I was like, "What's going on here?" Yeah.
Oh, it's good than mine.
Yeah. No, we definitely got Triton in here now. That's pretty cool.
We're about to lose it.
No, I'm gonna recenter it here. I think.
Or re-off center it, as the case may be.
Go back here. So I'm making adjustments to the mount here, and you can see it kind of flipping around. Get it back.
Yeah, so this is it back to live video mode,
right?
Towards
that upper corner there, so I'll just kind of move it back over here. And that's a 1/13 of a second exposure. Now let's go back to, let's start with 1. A 1 second exposure didn't have a whole lot of noise. There's a 1, but I don't see Triton in that one. So let's go back up to, here's 4.8. Should pop out at 4.8.
You're making me wish my monitor didn't have so much reflection. I'm like adjusting monitor settings to try and see this better.
Glenn Burgess just asked what we're looking at, and we're looking at Neptune.
Yeah.
I have up on my screen, I just thought I would show how Hubble sees Neptune, and it might surprise a lot of people to see that Hubble actually doesn't get that many pixels across Neptune's disk. This is full resolution Hubble data. And so the fact that any astronomer sitting on Earth under the atmosphere can get a disk on Neptune that looks blue and has a moon nearby it is really pretty freaking awesome.
There you go, Mike. You're pretty freaking awesome.
Thank you.
You're welcome.
It's not easy to find. It took us a little while to get it, but once we got it, we were pretty convinced we got it because we could actually resolve the disk of it, which Fraser didn't. He wanted to deny it. He likes this washed out view better, but I think down around this exposure here, and it's a little fuzzy now.
Well, it's just funny because whenever I post pictures like this, I always get comments like, well, can you please send a link to the full resolution?
Yeah, no,
sorry.
that is the full
resolution.
we only had like 12 pixels to work with here.
Yeah.
So Matt Arnold just asked if we could see Saturn next. Unfortunately, Saturn is down for all the astronomers here tonight. So we're going to be losing Saturn for a while, actually. But Jupiter's coming back. So we should be getting Jupiter in the star parties probably in late September, early October.
Jupiter is coming.
Jupiter is coming.
I like the way when you say Saturn is down, it sounds like it went offline for a little while.
Yeah, we've lost Saturn. We've lost the signal from Saturn.
That's
and
just
Mars,
the nerd in
unfortunately.
you, Pamela.
It is.
There's some bad.
It's funny. I thought Saturn was depressed.
Yeah, me too. We're looking at blue Neptune, like everything's sad right now.
Aww.
It's a sad, sad world.
Now, I just want to apologize to Corey and John. I know you guys are patiently observing some other stuff as well, but I sure don't want to lose this view of Neptune while we can. So we'll catch up on everything else shortly. Right. So Saturn and Mars, I guess, are starting to move. They're starting to move towards the sun, right? So we're going to be losing them, and then they'll become morning objects. So it's going to be a while before I guess Amit will be able to capture them for us shortly, because he's once we get a little bit the problem that we have with Amit's in Turkey. He's one of the astronomers and was joining us really early on, and he's a fantastic observer. The problem is that for him, when we start, it's already morning, it's already dawn, and so he can't contribute any images. So but as we move towards winter and we start earlier and it's darker for him in the morning, things are going to get a lot better. So we'll be able to get his help again, and that'll be fantastic because he gets to see a whole different view of the sky because he's observing in the morning. So it'll be Saturn and Mars, and then hopefully we'll be having Jupiter and Venus, I guess, at night. So it'll be great.
So somebody keep me honest here. I'm definitely seeing Triton, and I know Mitch is too. And I hope other people can see it too. Near my cursor here, it follows these hot fixings a little bit there. Now, I was doing some research to hopefully find other moons of Neptune, but apparently Triton has like the king's or lion's share of lunar density of the system, because there's only, what, 12? Emily, you know this.
Yeah, actually, it's a crime scene, actually. Yes. So you look at Triton's orbit, and you notice it's a little bit strange. It orbits backwards. It's the only large moon in the solar system that goes around its planet in the opposite direction to the planet's rotation. And that's a pretty good clue that it didn't form with Neptune. It probably actually is a Kuiper Belt object that we're looking at that was captured into Neptune's orbit. And when that happened, Triton's really big. It's bigger than Pluto. It tossed everything out of the Neptune system except for a few really tiny things that are quite close to the planet. So there probably did used to be a family of moons like Uranus's or Saturn's, but they're gone, long gone, mostly either eaten by Neptune or tossed elsewhere. Not to exit the solar system entirely, though, because I think Neptune can't do that, if I'm not mistaken.
The interesting thing about that, though, is Triton's bigger than Pluto, which means that if you're a Pluto's a planet person, then once upon a time we had not just 10 planets, but 11 planets, or just keep adding numbers.
Right, but Ganymede and Titan are bigger than Pluto too, right?
Yeah, actually, I had a really good graphic for that recently. Triton's one of the smaller big moons. So let me see if I can find that one.
It was actually the fact that it was actually not orbiting a planet, though, is what I was referring to, because there would have been a point in time when it was orbiting the sun rather than orbiting Neptune prior to being captured.
Well, it still may not have been seen the way Pluto was, because Pluto is both large and bright and close. So that's why it was seen 75 years before everything else. Let's see.
So John, to sort of make up for this, John has valiantly gotten the Saturn Nebula. So I think we should check that out for a second here. There it is.
It's so tiny.
It's so tiny.
Well, that's blue now. So.
It's about the same size. What is the Saturn Nebula? Is that a planetary nebula?
Yeah, I think so. Yeah, it's a planetary nebula. It's also known as Caldwell 55, which is the southern hemisphere version S, sort of the Messier catalog. And it's this little blob that it's mostly this green oxygen gas, and because of the way it's shaped, it appears to have a disk coming out of it, kind of like Saturn. So they named it the Saturn Nebula.
And I got to see what Corey's looking at, so let's just move over to Corey's view for a second here. It looks like a cluster. Is it the wild duck, Corey? I don't know if you can hear me. Oh, well, we'll look at Emily's moons. Go, Emily, go.
Yeah, so here's a graphic I put together. I forget what question I was trying to answer. I think I was talking about how small Mercury is relative to the other planets. So you have here from left to right, Mercury, our own moon, Io, Europa, Ganymede, Callisto, Titan, and Triton. And what's interesting about this is that, so these are all somewhat similar. They're about, they range over about a factor of 2 in diameter. And the jump down to the next biggest thing is quite a large one. You get down to Titania, which is 1,500 kilometers across. Triton's almost twice the size of Titania.
Wow.
And then Mercury, there's another big jump there because the next biggest thing after Mercury is Mars, which is, nearly twice the diameter of Mercury.
And Pluto's going to be smaller than Triton over on the right.
Pluto is smaller than Triton, yes.
Yeah. And have they decided whether Eris is bigger or smaller yet?
It's equivocal. There's not sufficient data to differentiate between the two.
So I guess the other thing that was weird for me was, though, that really I don't know that there were any other. The ground-based observations of Neptunian moons were fairly limited because I don't think there are a lot, and I think Voyager actually discovered the lion's share of them, but they were all really, really tiny. There was a large disparity, right? You had you had this captured moon, and then you have all these little tiny moons that were basically just little rocks of asteroids.
Yeah.
As I saw, there was a graph. I think it showed like 99% of the moons mass of Neptune were contained in Triton. Like the remaining 1% were spread across all these little tiny nothings.
Well, and the other thing that's weird is that if you look at sort of a diagram of where the moons are in their orbits relative to the size of the planet, the other 3 big planets in our solar system look pretty similar. And I keep on looking up because I have a great big cheat sheet poster above my monitor up here. But they all have kind of evenly spaced large moons that run out to about 20 or 25 times the radius of the planet. But Neptune just has this one big thing, Triton. The next thing in is Proteus, which is much closer to Neptune. It's only a couple of Neptune radii out. And then the next thing beyond Triton is way the hell out. It's Nereid. It's really far away. So there's this huge gap in orbit, in the orbital space around Neptune, that tells you that there really probably was something there a long time ago.
I think Nereid is, you can see that from ground-based telescopes, right?
Yeah, because it's quite far from Neptune.
Yeah, right. So it was discovered later because it was anomalously far, right?
I think well, Nereid, you can separate its light from Neptune, I think, more easily than the others. I mean, Proteus is so close. I imagine it was probably hard to resolve.
Yeah.
Has Neptune completed a full orbit around the sun since its discovery? Like, wasn't it just recently that it's...
Yeah, I thought it was just last year.
Yeah, like it's just recently completed one orbit, so I guess in our mind...
184 years, is that what it is?
164 years.
160.
So Keith Nelson wants to know why live Google Plus Hangouts aren't viewable on the iPad via Google Plus or the YouTube app. You might try the browser, Keith. Try going into with, Safari and go to the YouTube in the browser, and then go to the Universe Today YouTube page there, and you should be able to access the live feed there. So
that's how we were able to see that TAM on the iPad. I think it was actually through the Chrome browser with the full YouTube link in the browser.
So
we also have it embedded at cosmoquest.org/hangouts, and that should work.
Right. So if it's embedded, or if you do it from the website itself, then it works. But you can't actually see it in Google Plus, unfortunately, and you can't really see it in the YouTube app on the iPad. And that's going to get a lot worse, because I know that they're actually throwing out the YouTube app for the next operating system. So, Robert Scott Carrick says, "I'm blown away by how good the image of Neptune is. Wow." Agreed. Mike, you have continued to set the bar. This is amazing.
Brian Simpson says, "I'm going to use Neptune radii in the sentence this week." That is everyone's challenge. Use Neptune radii in a sentence at least once this week. I know I will, but I'm also doing a planetary astronomy class.
Can we say Neptunian radii? Or is that too much of a tongue twister? Neptunian radii?
Emily, someone's asking where Bill Nye is and when we can get him in one of these hangouts.
That's a good question.
He doesn't like space, does he?
What's that?
Does he like space?
He hates space. No, I'll get him on sooner or later. He's been traveling a lot this summer, and so I haven't been able to nail him down, but I'll try to soon. I've got about 5 more minutes, then I gotta go.
No problem. Well, you got a chance to see Neptune, which was great.
Yes, which is awesome.
So Darren wants to know sort of what's your gear, Mike? I think we haven't described what your technology you're using recently, but you can see it actually in the Google video that they did of the Hangout. You can actually see Mike's gigantic telescope as he drives it around his driveway.
I feel like a crazy golf cart driver or something. No, so in a nutshell, it's a 14-inch f4.5 Newtonian, and it's kind of a home built. I used some other amateur astronomers' designs shamelessly, and kind of really just pieced it together myself. And I like it. It's something that gives me a good amount of flexibility to do a lot of different stuff. I'm hoping to get a little bit better at my DSO skills, because they're kind of budding right now. And I don't know if you guys can see this. These are the shots I got of Uranus and Neptune from last year, and there's Triton kind of hanging out, almost in the same position it is this year.
Mm-hmm.
And I don't know how close these colors are. This is a color camera I'm using this year, so it's hopefully a little more accurate. The white balance is always a little iffy, but yeah, and certainly if you want to know more about my telescope, I think if you fish my profile out, there's a link to the actual specs and components and all that kind of stuff, and building photos. I'd never really considered myself an amateur telescope maker, ATM, but I guess I'm in those ranks now, and I'm happy to discuss things with people, bounce ideas around. Go back to the live view before it drifts out again.
Although it's strange, right, the Neptune in your photo had sort of more of a sort of pinkish, bluish color, and this one's a lot greener live.
Yeah, I think it's actually a bit more blue-gray than it should. So this one here was taken with a monochrome camera with color filter wheel, in a red, green, blue scenario, which usually means you got to do a little bit more legwork to get the colors right, especially on an object that's uniform in color. So I've always had a hard time because I've taken pictures of Uranus and Neptune since I think 07 or 08 in my 8-inch telescope, and it's actually challenging to get in an 8-inch. If you try real hard, you can get it, but the colors are always off because there's no contrast. Like when you look at the bands of Jupiter, you can say, okay, this is supposed to be white and this is supposed to be brown, but when you see a red, green, and a blue just blob, you don't know what contrast there should be between the features because there aren't any. Some people can actually get features. I think you can get the bands of Uranus under good conditions with a really good telescope in a certain kind of a filter from the ground, but I think it's probably beyond what I think I could do. Not ready for that challenge yet.
Let's go back to the live. Have we lost it yet?
Yes. No. It's. I think it's cleared the trees. It's just slipped a little too far off the edge here. We can bring it back. There it goes. Traipsing along. I always found it to be very gray and colorless to my eyes.
Just to interrupt, John Kramer just got a beautiful image.
Yeah, let me just switch over to that for a second, John. So, is that the Dumbbell Nebula? I don't know if, John, are you muted?
Oops, sorry about that. Yes, this is M27, the Dumbbell Nebula. Getting a little bit of color there.
Yeah.
This is another planetary nebula. One of the things a lot of people don't realize is one of the justifications for building the Hubble Space Telescope was so we could finally figure out what all of these things were. Planetary nebula have this amazing diversity of shapes. Just going from Saturn nebula to this one, you can start to get a hint of it. But really they go even more bizarrely shaped than the ones we've been seeing tonight. And it's only been with Hubble that we've started to be able to make out the intricate geometries involved and started to make guesses about how they might have been able to form the shapes they formed.
That's beautiful. That's a really nice image.
Yeah.
Are you sure you haven't done anything to change your methods this week, John? Because it seems, I don't know, it seems a little clearer, seems a little bit less background noise.
No, it maybe the transparency here and where I'm broadcasting from in Middle Tennessee might be a little bit better tonight. But
just good seeing tonight. Yeah, no, yeah. It seems just a little crisper, a little clearer. So no, that's beautiful.
Good.
That's amazing. There you go. So Roy Salisbury says he has the Hangout running in Chrome via YouTube and then AirPlay to the Apple TV on the big screen. And Roy Salisbury is one of the people who joins us and is totally welcome to join us in the Hangout itself, although it sounds like he's perfectly happy. But Roy has, if people know, he's got his remote observatory set up in the desert, in the Arizona desert, and I guess he's now got to the point where he can actually control the whole thing remotely and open up the dome and turn the telescopes all from afar. So hopefully we'll be able to get his help in future weeks. But of course, completes the project and terrible weather. So
I'll see if I can find it.
So by the way, I went the low-tech route. I take my laptop with a DVI output straight into the TV and I watch the YouTube videos that way, and it works great.
Okay.
Yeah. No, I like using AirPlay actually. It's pretty great. People want to know what my equipment is. So someone just asked on YouTube what my equipment is. Right over here is
Keeping it
my
high tech.
Celestron First Scope is my equipment. We don't actually get clear skies here, so there would be no point of having a telescope on Vancouver Island. Some kind of a rain gauge is what I would use. Let's go back to Neptune. Live from Neptune.
Yeah.
Gotta have a little flair once in a while, right?
Yeah, absolutely.
This is Mike reporting from Neptune.
I can only hope that someday that will be true.
That would be cool. I'll settle
Let's
for
send
Mars.
Mike to Neptune.
Yeah, no,
What you're saying?
Are you threatening me?
Are you threatening him? Yeah. So I'm kidding. So someone wanted to know. Yeah, where I grew up about 30 kilometers from here. It's actually it's a much nicer climate, and the weather is a lot drier and a lot sort of more often clear and beautiful dark skies, and I can see the Milky Way. But from where I am, and it depends on the weather. But here on Vancouver Island, summers are nice and warm and dry, and we get lots of clear sky. And then come September, it all just socks in again, and it's just rain and rain and rain all the way through. We get some clear nights, but not a lot. Like maybe, I don't know, 1 in 10. So it's pretty bad. So Emily, you've got to leave us.
Yeah, I'm afraid so.
Well, thank you for joining us for While You
Thanks for
Could.
coming.
It's always fun to see what these guys can do. You know, I look at space through robots that are doing all the hard work for me, so I don't have to do the kind of stuff that these guys have to go through to get their pretty pictures.
Well, we've got to do another one of those Q&A sessions to get another update on where
sure.
Curiosity was at. That was a lot of fun.
Is it my turn this week? I forget.
I think it's my turn this week.
Okay. So maybe the following week.
Yeah.
Sure.
All right, cool.
It was a pleasure, Emily. Thank you.
Bye-bye.
All right. See you
Bye,
later.
Emily.
Bye, Emily.
What a treat. That was great. So Emily Lakdawalla is the blogger for the Planetary Society blog, and is fantastic. So if you want like really great space news, when you finish reading everything on Universe Today, I highly recommend you go over and read the Planetary Society blog. It's great. Actually, Emily is one thing Emily does that's really great is she like stalks the NASA servers for images, and the moment new pictures come down, Emily is all over them. I think she was the one who grabbed that new self-portrait of Curiosity that just got posted. She was able to find it right away, and was able to sort of clean it up and rotate it and display it almost immediately. So beat us all.
She was a
to the punch.
blast to work with at JPL. Being able to work with her in person, she's awesome sauce.
Yeah.
Emily, you are awesome sauce.
Let's go back to Corey then. Corey, what do you got?
That's Swan Nebula through my unaligned Dob.
I can see the star trails starting to come in. So
I'm trying to fix that, but doing that on the fly is almost impossible.
You're flying and observing? You are awesome.
Yeah.
Hey,
Yeah, it's a
the
little,
Kuiper and Sophia observatories can do it.
Well, thank
Well,
you.
then why not Corey? Come on.
can you move to another object, John? Maybe Andromeda?
I can try for the Andromeda Galaxy, sure. This
That'd be great.
particular setup doesn't usually do very good on the galaxies, but I will definitely go for it.
Sure. Give it a. It's so bright. But people were nagging us all summer, like, "Where's Andromeda? We want to see Andromeda." So, and they want to see Orion too, of course. But you know, come November, December, they're going to get sick of Orion again, because that's the one our go-to object starting in December. But that's great.
Right.
Yeah, it's.
Moving to
I thought we were only going to have a
M31
few
here.
seconds with Neptune, Mike, but it's been here the whole time. I'm getting kind of bored of it. No.
So one of our awesome astronomers, Teal, he's being a smart aleck, and that's why I love him. But no, Mike cannot be live from Neptune because light travel time is around 4 hours. So even if he was live from Neptune, we wouldn't get it for a couple hours still.
too interactive for you, huh? I might be able to shoot Uranus here. Let me give it a shot.
No.
That'd be awesome.
I don't know.
It's 2 degrees lower.
Don't quote me on that. Let's just see. Hang on.
Oh, it's on the internet, Mike. I'm sorry, man.
Yeah, just said it. All right, so you heard this. Mike has just promised everybody watching that he's now going to display Uranus in view.
Oh no, me and my big dad.
If not, John, can you go after the Ring Nebula? We had a request for that. So
I have M31 just about right here. It looks like in the bottom portion. So yep, we can try Ring Nebula after the Andromeda Galaxy.
yeah, I see what you mean though. It's almost like there's not a lot of contrast in the image because it's really hard to like. It's not a very distinct object, right?
I mean, it looks like I can almost pick up a little bit of the dust lane there, but
yeah.
Yeah, it's just hard to tell at that exposure.
Of course, here's the center of nucleus of the galaxy coming in.
Well, that's pretty nice.
It looks like you're having some tracking issues, maybe?
Oh,
Or
I'm
is-
centering.
It down right now.
Okay.
Yeah, I'm centering those up. I'm centering it up a little bit
Okay.
here, but just trying to get it framed a little bit better.
I don't recall that exploding center of Andromeda, but here's what it should look like. So Scott's got Great Nebula in Andromeda in Stellarium.
Yes.
That's cheating.
Well, I'm gonna take this opportunity to do some shameless self-promotion, which is I'll show you this here. We built an app for Android and for iPhone. I'll show you this here. It shows us the phase of the moon. Check it out. What's cool about it is you can move it back and forth, and it shows the right lunate with the libration. Is that right? And actually the size of the moon, so you can actually spin it too. Just give it to the kids, let them spin it. You're not actually spinning the moon, of course. You're just spinning the phases, but it's really neat. So it shows the distance accurately and the actual sort of how the moon appears to wobble back and forth. So that was some shameless self-promotion. You could buy it on the Google Play Store or the or iTunes.
And it is really pretty.
It's really cool.
I
yeah,
have seen it, and it's great. I really do like it.
Yeah, and so now we got to add, like, we got to flip it for people in the southern hemisphere, and we got to add moonrise and set. And the other thing I want to do is I want to put like a drifting star field that goes behind it. But actually, when we did the math on how much, it's called phases of the moon. So, but actually, we've got if you go to Universe Today, on the right-hand side, there's a little widget there, and there's a link there that you can move to the iTunes Store or the Android Store. Right, so yeah, so I want to put like a star field in the background, but the problem is that realistically there would just be like one star that would almost never move, like it wouldn't be very exciting. So I think we'll fake that part and actually have, fast drifting stars, and then put some disclaimer that says, drifting stars, not scientific, but look cool. So.
Yeah, then you're just going to get smited by Neil deGrasse Tyson.
That's right.
Bring it on. If he'll chase me down and show up in one of our hangouts, then it'll be totally worth it. I will fake all kinds of science to get.
Well,
Neil
I don't think you
deGrasse
have a
Tyson to
budget
come
like
hang out with us.
Titanic does anyway, right?
No, we don't.
Oh, yeah, that's right. He was really mad about Titanic, and he actually got James Cameron to redo the scenes in Titanic to have proper constellations.
As he should. If he's re-releasing a movie, how many years later, make the stars correct? I think so. We have this technology, and he's got billions of dollars to go for it.
Yeah. I will. I'll give you guys a link to the app here. It's really interesting doing mobile development. It's a whole other world, I gotta say.
Well, since we're speaking about shameless promotion, CosmoQuest yesterday announced our new citizen science project, Asteroid Mappers.
Yeah.
With the Dawn mission now leaving Vesta, we now have a bunch of image up from Vesta where you can go and map the craters. And it is wonderful. We had a great time with folks from the Max Planck Institute in Germany, a bunch of people here from NASA, JPL. We had like a 2.5-hour hangout yesterday. and it was a lot of fun. But so yeah, you can head on over to cosmoquest.org. If you already have an account, you can just get right on over with mapping craters on Vesta, and we're getting everything worked out for it. But it's a lot of fun, and the images are gorgeous. I mean, if you like mapping the moon, you're going to love mapping Vesta, so go for it.
And even if you didn't like mapping the moon, you'll like mapping Vesta because the images are much cooler.
Yes,
but it's
really
all
great.
new. Like I think it's important that people can understand that we're actually now discovering stuff that, no images this high resolution have never been taken before of Vesta, and so this is.
And not all of these images are publicly accessible yet, except through our interface. So you might be the first person outside of the Dawn mission to see some of the images that you're looking at.
That's really cool. How's it coming, Mike?
We had it in the eyepiece, and it was in the camera, and now it's gone. So I gotta just redo what I had done to get it, but pretty sure I got it, and I think it's not at risk of going behind trees. So patience is a virtue.
In astronomy, no, there's no patience in astronomy ever.
And this is probably the best M31 I'm going to be able to pull out.
It's a really good one.
Yeah, it's great. You can see the central core. You can see some of the dust lanes. It's a little. It's almost like it's too big and it's too bright for this venue.
Yeah, this is with I got a f3.3 focal reducer on there, so it's an 8-inch scope. And yeah, it's the same focal reducer I've been using, but yeah, I'm surprised that it's even larger than what I can fit into the field.
So can you try the Ring Nebula? We had a request. So what? So you're
Sure.
our go-to. Oh no, wait, Corey already did it.
Oh, that was a plane going through M31.
That was impressive.
So Corey, you got the Ring Nebula for us, I think, right?
Yeah.
Sweet.
Yeah, there it is.
There it is. All right. Well, why don't we move to the Let's Take Requests phase of this evening, either from the people watching or from anyone who's in the Hangout. Otherwise, it'll just be me, what I want to see. Although I'd love to see, John, any think you could try getting M13?
I think M13 is too low.
Really?
Yeah, M13 is already set, I believe. No, maybe not. There it goes. It's not that low. Yeah, I can try for M13.
Yeah.
I think I can see the central star in.
Yeah, I think I see it in your view.
Barely.
But the star that you see in the center of the Ring Nebula is not the white dwarf that's in the center of the Ring Nebula.
That's
just
right.
to make it clear.
Smaller, isn't it?
Yeah. So this is a star that's behind the Ring Nebula. It just happens to be perfectly lined up. Isn't that a bit of a coincidence, Pamela?
Coincidences happen. It's a big sky.
The universe is huge.
Think of all the Ring Nebulae that are out there that don't have a star that we can see in the.
Well,
them?
Just another viewer looking at this Ring Nebula won't have that alignment. It's just we're in the right place at the right time as everything's orbiting.
Now we have to go see Cosmos and watch Carl Sagan talk about the constellations and how they move. It's going to be the same concept, just over time. They just happen to be aligned, and we see something up there that looks like a hunter.
Now, are you all looking forward to the new version of Cosmos as much as I am? Isn't this just going to be the best? With Neil deGrasse Tyson, with Seth MacFarlane on Fox.
It's that Fox
Yes.
part that has me worried.
I'm glad it's on network television. I think that's fantastic that it's on network television. So people aren't going to have to pay for a cable subscription. But
I just know how quickly they've canceled things like Firefly.
Look at that. Look at all these moons.
Oh, come on. Have you done it again?
Yes. I think this bright one here is a star, but there are, hang on, wait, I'm going for a longer exposure.
neat.
1, 2, 3, 4, or maybe 5 right there.
Oh, come on. Really?
There's a lot of moons of Uranus, and it's closer.
This is insane. I cannot believe you did
That's
this.
awesome.
There, right? 1,
There you
2,
go.
3. Is that one there, too, for 4, and then a 5th one up there? Somebody go pull a chart up.
That's awesome.
Let's go. Let's go longer here. Let's go to 8. I don't know. This is a low magnification too, so I should be able to pick a lot of them up.
4, 5.
But one on the left is too bright to be a moon. That's definitely a star.
Yeah, that's a star, but
one there,
the others, they look very moonish.
Yes, and they're all a nice little line there, right?
The moonosity is definitely there.
So we need a full map to tell us.
Well, we got all these nice, wonderful, scientific people here. Someone's got to know. I'm going to update my lower third.
So we got a request from Digital Cosmos for Eta Carina, which we can't do because
That's Southern Hemisphere. We need a Chilean observer.
or Teal to.
Yeah, but
to
he's
somehow,
daytime. We need.
I know we
night.
got to do a special Teal event where he gives us a view of Eta Carina from the Southern Hemisphere.
Teal, you are always special to me, just so you know.
I still want to see the Magellan Clouds.
Yeah, I know. So we should do a
They're
special
beautiful.
observing
Maybe during
night
the
with
day,
someone
it'd be
from
nice and easy.
Australia, or get Peter to set up a telescope where he lives and actually display,
Yeah,
as
well,
opposed to using a
iTelescope-
telescope in Arizona or New Mexico, right?
iTelescope does have telescopes getting set up in Australia, so we just need to get on it. Maybe get some South Africans in there as well.
Well, the iTelescopes people have been really generous, and they've totally offered to let us use some of their telescopes. So we just have to get around to use them. Feel terrible, but we've got some big telescopes that we can use kind of whenever we want. But I kind of like having the sort of regular folk with their telescopes. So that's amazing. What a wonderful night. I can't believe I was sort of feeling a little worried that it was going to be a sort of series of disasters with trees and especially how it started. But Mike, I can't believe you're like, oh yeah,
Pulled it out.
you pulled it out. Yeah.
My beavers and chainsaws were fast at work for Neptune. And we're gonna see, I think I'm going to up the magnification here just so we can see the nice little disk in the same magnification that Neptune was at. So you see the size difference.
Be
So,
careful.
Excellent.
Yeah, don't break anything. Let's.
All right, I got M13 too here.
Oh, okay, great. While Mike's doing that, we'll check that out. So there you go. And oh man, that's beautiful. Wow.
So you're using a different type of camera than the other guys are, John. What are you using?
I am using a Samsung SCB2000. It's a surveillance video camera that can actually ramp up the exposure time to about 8 seconds max, but this is only about 2.1 seconds.
Okay.
So it's in very close to real time. And yes, I do have some tracking errors this evening. I can see in the trails. But
yeah,
it's still
fairly minor though.
not bad.
But yeah. Let's go back to our moons.
Find out that if you don't have tracking errors every once in a while, you're not doing it right.
slightly out of focus now. Touch the focus a little bit. It looks bigger than Neptune, does it not? Is it me?
Oh yeah.
Yeah.
And Corey, if you're listening, your universe needs to be plugged in. I'm not sure if you really. Your Cosmos is at 7% battery life.
Yeah. There it goes. Plug in or find another power source. And can you pull something else up, Corey? You want a suggestion?
At 7% power.
I suggest M16.
M16. All right, I gotta look it up.
And Eagle Nebula. Actually, that was Roy asked for it. So
I tried for the Eagle Nebula earlier, and it's too low and too dim for my tracking and my setup right now. So
all right.
I was just right now looking to try and get the wild duck, but then.
Sure. How about the double cluster in Perseus?
That might be too big for my field of view. Actually, I'm gonna see if I can get the wild duck before my battery dies.
Okay.
And then I'd probably just have to go after that because.
Well, I think when Corey's battery dies is when we'll wrap up this hangout. But so I'm seeing the moons, but they're pretty dim, Mike.
Yeah, this magnification doesn't lend itself for those moons. I can go back.
What about just a longer exposure? Just blow it right out.
Yeah, I did. I went to 9, but it's not updating very fast here. I don't know if it has to go through two cycles of this or what. 9 point. Okay, 9 point. Yeah, even a 9.7. I don't. Well, you know what? This focus might be off too. But if you want the moons, I'll go
had a
back
request for M104, but I think it's down. Yeah. So no luck for that. Had a request for M92.
Yeah, M92 is right in the neck of the woods here, so I can go to that.
Yeah, M92 should be okay. It'll look very similar to what you've already got, John.
All globulars are not made alike.
That's right.
Some are globular and some are globular, and we need to learn the difference.
There's different classes.
Yeah, there's the Oosterhoff type 1 and Oosterhoff type 2, and what's kind of neat is they actually rotate, and not rotate, they orbit in opposite, I can't do it with my hands, I'm too jet lagged. They go in opposite directions around the galaxy, and they actually have different elemental compositions, different metallicities is what we normally say. And it's thought that one of the Oosterhoff classes was probably grabbed violently off of something that the Milky Way galaxy ate at some point in our history.
Sorry, you're very typey, Scott.
Sorry about that.
There's the wild duck.
Done.
And yeah, my tracking errors are showing, but that's okay.
So now we can see open cluster versus globular cluster. And what's interesting is the open clusters are among the open are among the youngest objects in our galaxy, and globular clusters are the oldest objects in our galaxy. And both of them are sets of stars that all formed at the same time, but the difference is that the open clusters are going to get shredded from basically the ones that are closer to the center of our galaxy orbit faster than the ones that are further out, so differential rotation shreds the system. The globular clusters, their self-gravity is stronger than anything else, so they orbit as a mass as they go around and around the galaxy.
How different is the magnification, Mike, of this version of Uranus from what you had with Neptune? I said it. I'm a purist.
It's Uranus.
It's Uranus.
Has anybody seen the CGP Grey how to pronounce video? I think I'll have to post that in the YouTube comments or something as a video response.
I know how to pronounce it properly.
Well, no, there was the Greek or the Roman pronunciation was Uranus.
Uranus.
Is the original proper way to say it, but nobody knows how to or doesn't want to say Uranus. So we all say Uranus or Uranus.
Respect for it.
Right. My coworkers just love to pick on me over that one. And no matter how much I correct them, they don't care. So this is the same. I have a 2.5x power mate in front of the native 4.5. So I don't know. You do the math. It's the same as the Neptune views we were looking at before.
It's strange that it looks the same size. Ish.
Yeah, I was thinking it would look a lot bigger than it did, but it might just be subtly bigger, and it might show up better in a stacked view. So if I can take a quick,
it does look subtly bigger. I'll give you subtly bigger.
Very subtle, though. Yeah. But I think they're physically both really close in size, though, right? I mean, so the only difference is that Neptune is further away. Versus something like Jupiter, which is a lot bigger and a lot closer than Saturn, so they exhibit a lot more difference in size. I think Uranus and Neptune being close in physical size, the only difference is the distance. Pardon me while I shut the color off to make a recording.
All right. And we do have M92. A little bit settled down here for that person that wanted to look at M92.
It's nice.
Well, I changed the.
Yeah. It looked very similar to M13.
I don't know. To me, the M92 has a much more condensed, brighter core than M13 does.
It does, actually.
Yeah.
M13 is one of the fluffier ones.
And here's the computer simulation of it from Scott. Yeah, you're right. It definitely does, doesn't it? And Corey, you've got a binary star there?
That's Alberio, or however you pronounce it.
Oh, that's
So
awesome.
if this was in color, those would be two remarkably different colored stars.
I can do that. I just have to take the filter off. I've got a ultra high contrast filter
Okay.
on right now, so.
This one's worth pulling it off if you can do it easily.
So, John, I got a request for NGC 6888, which is the Crescent Nebula. Think you can do that?
6888. Okay. I will try. Sure.
Now, that's part of that, of like the Veil Nebula and all those ones, right? Think?
I know it's in Cygnus.
Yeah. It's the remnants of this leftover supernova explosion.
Well, let's see what we got. I might have to up my integration time, which is going to really magnify the tracking, but let's see what we got here.
Destroy your telescope and computer if you have to. I don't care. Whatever it takes.
I'll do it for science.
For science.
For science.
So, Mike, it's changed color, or is this that star that's beside us?
No, I do the recording in black and white, and I do the color filtration of it later. So it's only for recording. So I'll turn the color back on. Don't worry.
BTL 743, we're absolutely reading this. So, yeah.
All right, I've got a
we're reading
color
that.
Alberio
You met Ron
coming
Howard
in.
and told him that
There's
Apollo
color.
13 rocked, which is true. So,
Got your color back.
Darren Road wants
There's
to know when
your
the astronomy
Alberio.
cast starts back up. So we've got we actually just posted an episode today, which was one of the last ones we recorded, and I'm not sure why it didn't get up before today. And then we've got our live show that we did at DragonCon, where we talked about space funding, money in space. And then we're going to be recording, I think, tomorrow at noon.
Yep.
So we'll put that in the
Noon
calendar.
Pacific, 2 Central, 3 Eastern. The rest of the time zones are on their own.
Yeah. No, we
There's
like
there's your color Alberio if you want to look at it
Oh, that's beautiful.
before my battery dies.
Yeah.
that's
That was
great.
so totally worth it.
Oh, wow.
Absolutely.
That's awesome. This is one of those times where you can really see that stars have different colors.
Yeah.
I'll be able to get a little more color out of it if I shorten the exposure time.
And John's got the Crescent Nebula there for us. Pretty dim in this view.
Yeah, I tell you what, give me a moment. I'm going to go out. I don't have a way to do it remotely. I'm going to go out and increase the exposure here and see what I can do.
Like I said, destroy your telescope if you have to.
And for information, the Crescent Nebula is in the same area, but it's not part of the Veil. It's Cygnus.
Oh, it's not. So it's not part of that same sort of network of explosions.
No, the Veil Nebula, it's got a big area,
Yeah.
but this is off away from it.
That's a fantastic view, Corey. I don't think I've ever seen
Yeah.
Alberio as nice as what you've got right now.
Well, I think one of the things that makes it look so awesome is the diffraction spikes from where the spider is that holds his secondary mirror are just basically in the larger star is embracing the blue star. And that's just an
It's
awesome
beautiful.
alignment of the diffraction spikes.
Oh, man.
Pamela, is that a true binary?
No, it's just a double.
But they are orbiting one another, I guess is the question.
No, that's a binary. A double means they're just superimposed.
Right. Okay. So they just happen to be close to each other.
Yeah.
Yeah. Okay.
So 7% must mean about a half hour, because I don't know.
That's what it is on my MacBook Air. So.
Well, this is not nearly that expensive.
Well, my
of a
MacBook
computer.
Air is pretty old. So.
Oh, okay.
Unless you're doing an eclipse, and then 7% means 5 seconds from now.
Yes,
and then it just cuts it off.
So I think that BTL 743 is trying to troll us now. Where she says that we lost an astronaut, Bear Michael Clark Duncan from Armageddon, and then says Armageddon is probably the most realistic space-related movie ever.
No.
If you're trying to troll us, BTL 743, well played, because
you did get us to laugh out loud.
Yeah, well, and about to fly into a rage about the science in Armageddon.
Liam Mystery Science Theater was.
Have they done a take on it?
I don't think so.
No, I'm just saying it's not scientific.
Could we do that? Could we do a Mystery Science Theater version of
it would
like a
cost us so much money
Armageddon?
to get the rights for it.
We don't need to get rights. I thought you did for riff tracks. You don't need the rights. You just record it, and then people just.
That's true. We could do it. Everyone sync right now. Yeah, that we could do.
And then watch Armageddon, and we'll tear apart the science in it. That'd be great.
And I've actually never watched Armageddon, so you get to see. I've seen clips from it, which have prevented everyone in my life from ever letting me see the movie.
We should do that as a hangout sometime. I'll try to figure out the legalities of that. That would be fun.
I did do Manos Hands of Fate Hangout on Air Mystery Science Theater with Charlie and a couple other people being dorks.
Yeah. So people, in other words, would find some way to watch the show somewhere else, on some other TV show, or watch it on video or Netflix or whatever, and then we just watch it with them and do it as a live hangout, and then they could post comments and stuff. I like this idea. I'm gonna figure this out. So, question from Liam Cash: how often are Uranus or Neptune watched? This is the first time we've ever caught them in our virtual star parties. So, there you go. They're very hard to see. Mike has a super fantastic telescope and nerves of steel and perfect seeing conditions. So it's just a great night for this.
Yeah.
Luck. A little bit of luck.
And a little bit of luck, yeah.
And a lot of skill.
Yeah.
Yeah.
Oh, you have moons again.
Oh, yeah, there they are.
Yeah, I'm hoping to get a recording of this and stack it later. Count them all up. Did anybody pull a finder chart up of Uranus's moons?
I can pull it up here with Stellarium.
I think I got at least 1, 2. I thought there was a third one here, and then maybe another one over there.
Yeah.
I thought there was one. There's one. Yeah, I think Ariel is bright enough to be seen, but is really close, like all the time.
You did have one, Rob. Started earlier.
So,
too. Here we go. Okay.
I did get Phobos and Deimos this year too.
So here's a simulation of it on Stellarium.
Let's see.
Oberon, Titania, Umbriel, Miranda's just behind it, and then you got Ariel on the other side of it. Let's take a look at your view.
And then here's that star he's looking at, I believe, right here.
Yeah.
Yeah, that makes sense.
I wonder if it would occult it.
I don't know which way it's moving. It has to be so perfectly aligned.
Run a simulation, Scott. Go backwards or forward and see what you can do.
Well, let's see if I can pull up its orbit real quick.
Yeah, but just go backwards and then really fast and see if it's moving towards it.
Then I'm going to put it in front of everybody's view. I can't see what you guys are talking about.
Oh, no, they're drifting. Okay, yeah, so you see what it's doing?
Yeah.
So it's not going to occult it.
There we go.
Is that just individual days?
That's one day.
Really?
Yeah.
Wow, okay.
And these are hours.
So I know people are kind of watching this. So what? This is Stellarium that Scott's using here, and so it's gives us a simulation. You can really see, like, there's that star right beside Uranus, and then as as Scott shifts the days up and down, you can see how the Uranus system is moving compared to that star. So there's no way. I was hoping there might be some kind of occultation where Uranus was going to move in front of that star, but clearly not.
All right, let me move it back over. Let's see that other star there just for extra reference.
Fraser, this is one of the clusters in the double cluster.
Oh, it's nice. Oh, so it's only one of them, so it's just
Yeah.
the field of view is just too tight. Yeah.
Okay.
I still need someone to show off the coat hanger cluster, but it's just maybe Scott, you can do it. But it's just such a large object that I love to show it off in binoculars usually.
And there's that orbit if you wanted to see it. So.
Well, we're pretty much at like about an hour and a quarter, and I think we should probably start wrapping things up. And still, Mike is delivering the goods. Unbelievable. I'll bet you Jupiter's going to be up for you in a second too, isn't it?
Let's just keep going.
Then we're just going to keep going. This is going to be.
And then Mike's going to make first contact with intelligent extraterrestrial life. And
Yeah. Fine.
Not to derail this
Mike,
anymore,
you
but I
win.
actually did add an SSID to my home network that said alien invasion landing craft number 429. Just to freak my neighbors out, you know? Like, what is this network I see?
One of my neighbors has theirs is called Virus Installer. Which
There you go. Virus.exe.
Yeah. Great. Okay. Well. Thanks, Mike. This is phenomenal.
Yeah.
I mean, what a treat. I'm really amazed that you were able to do both of them tonight.
Me too. Yeah, in the same night.
In the same
Amazing,
night.
Mike.
That's just phenomenal. And I'll bet you could pull up Pluto too if you really felt like showing
Yeah,
off.
I think it's going now. But I want to say somebody can run the math on this one too, or simulations. When I was little in high school, Uranus and Neptune were very close to each other, and I think almost within the same binocular field of view. So Uranus, obviously being closer, is moving a lot faster in the other direction towards the morning sky. So it's kind of interesting, you know, in that time since high school was a little ways ago, to see how far apart they've actually gone now. Not far enough that you can't catch them in the same night yet. Pretty cool.
I wonder if someone should run a simulation and find out when they're actually going to.
Well, when were you in high school?
In the same field of view.
Yeah. Let's not talk about that, Scott. Yeah, like late 80s, early 90s. I want to say like 1989, 1990. They were like in Sagittarius together.
I can take a look.
This is one of the other open
when,
clusters.
Pluto shifted behind, or closer than Neptune. And then when it shifted away again.
Yeah, 99, I think. Because I actually have a college book that talked about it being in the future, because I graduated college in 97.
Okay.
But, you know, the irony is that it's not a planet anymore, so nobody cares. Huh?
Yeah.
I still
matter
care.
anymore.
I took a picture of it.
Oh, we lost Corey's battery just went, so I think, as I said, that is our sign.
There you go.
So thanks, Corey. Unfortunately, I didn't get to say goodbye to you in person. Thanks, John, for bringing those beautiful views, especially the dumbbell. That was fantastic. Thanks for Gary, although, Gary, we need to hear more from you next time. I guess you can't really talk unless there's a telescope in front of you, so I understand that.
Nothing to talk about.
And thanks, Pamela, and thanks, Scott. Hey, look, there's Mike.
Yes, wait, we're going to turn a light on. I've got Mitchell here, too.
Oh, cool.
Oh.
Yeah. We'll give you a proper goodbye, I guess, right? Get your light out. Hey, what's this thing doing? It's dark out here, guys.
There they are.
There we go.
Hey.
Fantastic work, guys. That was
Live
just
from
very
Uranus.
All right, live from Uranus and Neptune.
Special treat for everybody.
Mike and Mitchell signing out. All right, guys. Thanks a lot.
Good night.
See you guys later.
Take care,
Good night,
everybody.
everybody.